Okay, good morning. So today we are officially starting the module number two, which is actually related to different fields. But the first topic is sensors and actuators. Then we will be seeing some more topics on chassis and other control, and finally we'll be finding the steering and other control related to a vehicle. So in our syllabus, there are mainly two chapters or two modules which are related to uh, automobiles directly and the internal part of it and functioning and all. So major part of it is already covered in module one. So there we have seen battery system, charging system, starting system, ignition control and all. So where mainly the sensors are connected, we have seen. And in engine actually for power control, what all sensors are required, that we will be seeing today. So in this module, that is module 2, there are three subtopics or there are three submodules, and sensors or actuators are almost 50% of this module. That is module 2. So there are around 13 to 14 different types of sensors which are kept in the topics in the syllabus. So we'll be discussing that one by one. And we know many sensors and actuators. So more than knowing about the sensor, how they are actually affecting the measurement process inside the vehicle, or how they are actually helping the control system, because whenever we are saying sensor, they will be picking up some kind of data, some kind of measurements, and those measurements will be used as a variable in the vehicle control system. So yesterday we have seen ECU, that is the electronic control unit. So electronic control unit is connected to all the sensors. So all the sensor data is actually going to ECU, and they're stored and processed as per as the algorithm that is stored in the vehicle. So you are officially starting the module number 2, and in module number 2, first subtopic is sensor and actuator. So we will not be doing many things today. Mainly we are going to see a big block diagram, which is the block diagram of basic sensor arrangement inside the vehicle, and that too for mainly engine control system. So inside the vehicle there are many sensors for our comfort and all. There are many sensors for seat adjustment, you can say, for mirror adjustment, for AC, for song, for the taking the car back. There are many sensors like that, but main here basic sensor arrangement is discussed first for electronic engine control system. So in the engine, we have not seen much. We have seen battery, starter, ignition, and charging, all those things, but they're actually surrounded to the engine, and engine is the main thing that was started by the starting system. But we have not studied engine much. That is actually the scope of mechanical engineering. But yes, in engine, overall engine system, it is not only engine, overall engine systems, and for control, what all sensing things are there. So we will see a big block diagram today, and we will be discussing that today. And next we are going to find what all are the variables that are to be measured in the overall control system. And finally, one very small sensor we will do today, and that also we will not do to the full, but we will see what is the airflow rate sensor. And it's a very simple Wheatstone bridge structure. We will see that today. Okay, so this is more or less today's topic. And as we are starting this topic today itself, module today itself, so we'll not go into in many directions. So this is mainly kind of an introductory session for this module. And after this, third, fourth, fifth module will be totally related to control system. So this is a final module related to the vehicular system explanation. So every word, so there are only 6 to 7 slides in today's lecture. So we are having time, we will go a little slow. You can find this thing. So for this module, at least for sensors and actuators, I will be following the book authored by Ribbons, and 7th edition, 8th edition, all are given to you. So you have to go to page number 184 of book Ribbons, which is the 8th edition. It was already uploaded, the PDF. So previous whole module we have done from the book of Denton, chapter number 5, 6, 7, 8 in that. But for this book, Sensors and Actuators, we will be following the book of Ribbons, 8th edition, page number 184. So let us start this. It is said that in any control system application, sensors and actuators are the critical components. So they first uh, measure some parameter, they develop some electronic or electrical signal, and those are actually used or controlled. And those are the signals that are used for determining the performance of the system. Likewise, if vehicle is running with very high speed, in that case, there is a sensor to sense what is the speed of the vehicle at any time. Depending on that, we have seen the rectifier frequency will get changed. Okay, so the rectifier operation, how fast the battery will get charged, that is actually a indirect component, or that is actually an indirect thing related with the vehicle speed. So everything in a vehicle is related, and vehicle speed, which is measured by a speed sensor, is a very important parameter. A lot of other parameters are related to it. So actuators will be doing the job after sensing. So sensing is done first. Depending on the sensed parameter, the microcontroller kept in the car, it takes the decision that how much of the fuel to be injected, how much speed variation is to be done, what would be the criteria for charging and other things. And after taking the decision, actuators are the components who are actually getting the execution done. Okay, so sensing first, then decision making, and then actuation. I told you, if there is a mosquito bite, so our skin, there are sensors, it is sensing it, the signal is going to the brain. So in brain, the decision is being taken that the mosquito has to be hammered. So if there is a mosquito on our left hand, then brain takes the decision after sensing, and then the right hand acts as an actuation or actuator. It goes and kills the mosquito which is sitting on the left hand of us. So this is a sequence we have to remember. Sensing happens first, then the sensed signal goes to the ECU or the brain or the microcontroller. Their algorithms are there, decision is taken there, and then the brain or microcontroller, it sends the signal to the actuator that you do or you get this thing done. So actuator actually executes it. So sensor and actuator hence is very important, is a combo. Okay, so together they sense and get the work done to bring the vehicle in a very perfectly controlled environment. So both are critical components by determining system performance. It is true that all vehicle control system is true for all vehicle control system application. That is sensing and actuation. These two things has to happen simultaneously. The availability of appropriate sensor and actuator dictates the design of control system and the type with which it performs or its function. So best quality sensor, then best quality algorithm, and finally proper actuator. So previous day cars in 60s, 70s, 80s, they were having sensors and actuators, but decision making at that time was not very proper because microcontroller and all these things were not there. That's why very smart kind of vehicle control was not there. So nowadays microcontroller are there. It knows the engine capacity, it knows what all can be done with the engine, and depending on the input condition, microcontroller takes decision accordingly. So yesterday whenever I was discussing about ECU, I told that in very primitive or simple kind of ECU, 16 different cases of engine operations, 16 different cases of load variations, all these things are already input. So whichever engine we had discussed yesterday. So if any of these cases arise, then the ECU will act accordingly, the actuators will act accordingly. So those are known cases. Okay. So nowadays car, it is having a lot of AI, ML induced in it. So it of brain. Okay. So the availability of appropriate sensor and actuator. So sensor is a thing which generates a signal which comes towards the ECU, and in ECU the decision is made and it gives a signal to the actuator. So sensed signal is coming toward the ECU, and actuator signal is going from the microcontroller towards the actuator. So it's an outward signal, and sensed signal is a inward signal. This is a direction you have to remember. So sensor and actuator dictates the design and control system and type of function that a vehicle can perform. That means the smart functions that the vehicle can perform. Next paragraph, it is said that sensors and actuators that are available to control a system are not always what the designer wants. Okay. So exactly custom made thing might not be available in the market. Sometime the vehicle designer has to take or by default he has to accept some of the sensors and actuators which are already available in the market. So they are so widely available that they have become the standards. Initially, when the sensors and actuators came in the market, they were having very low usage and all. But then people started using, designers started using them heavily, and now they have become very widely accepted standards of sensors and actuators in the market. So if a new designer is there, he doesn't want to use that kind of component. Maybe even if he doesn't want to, but he has to use it because those are the most widely used, most widely tested sensors and actuators in the market. So it is the second line of the second paragraph. It is said that even if the designer doesn't want it, but he has to sometime accept it, okay, because they are the only commercially available sensors and actuators in the market and well tested and they are well performing, but always there is a scope for improvement. If the designer wants, in that case he can design his own sensors and actuators. So that we will see in the next in the consequent lines what exactly it is. So for the reason, special signal processor or interface circuits often are to be designed to adapt an available sensor or actuator. So actually car design is getting modified or car designing is being guided by the already available sensors and actuators in the market. Okay, so we have to design special DAC, that is data acquisition system. At a certain time, maybe we have to design special signal processor or interface circuits so that we can accommodate the already available components in the market. So even if the designer doesn't want to, but he doesn't have any other choice, he has to go and use all the already available sensors and actuators in the market. Specific way to fit available sensors or actuators. So for fitting the available actuators or sensor, we have to design specific signal processing circuit and specific control circuit to do that. Okay, so it is often worthwhile to develop sensors for a particular application. Now we are coming to the modern day car where very specific features, very specific sensing and application things are actuators in the market are not being used. For that, very well designed, custom made sensors and actuators are being developed. So, second paragraph, last two lines is important. It is worthwhile to develop sensors for particular application. So this car are coming for with some specific, very specific feature which are not there for other cars or vehicles, and that has become the selling point. Okay, but for that expenditure is more, for that effort is more, for that newly designed sensors and actuator the designer has to design. So it is often worthwhile to develop sensor for a particular application even though it may take long and expensive research project to do so, but it is worth. Okay, it will give us the exact performance, the special performance that we want from the car. So there are two types of design. One is whatever things are already available in the market, well-tested sensor, well-tested actuator, take that and designs very specific circuit or signal processor or maybe interface or DSPs with that, and then design your car. That is one way. Second way is designing everything from the scratch. That is sensor, actuator, signal processor, microcontroller, everything has to be assembled from the scratch, own design, custom made design, and then it will take much longer time to design the car. The car will be much expensive, but there are always buyers for such very expensive, high-end, high-performing cars. Okay, so choice is in the hand of the buyer. Okay. Although there are many subsystems in automobiles that operate with sensors and actuators, the discussion will start with a survey of the devices for powertrain control. So we have not so far discussed engine and powertrain control, which is mainly a mechanical part. Okay. So in that there are very good sensors, there are very highly performing sensors. And I think the engine and the powertrain, they are the heart of the vehicle. Like the main part of our body is the heart and the blood, that system. Okay, that is actually everything is happening. It is connecting all part of the body. Okay, it is taking all the food to different cells, all the oxygen to different cells and all. So powertrain and engine is like that heart of the vehicle. It is generating the power, it is taking the power to different corners of the vehicle, and vehicle is running because of this engine and powertrain assembly. So in that, what all sensors and actuators are there to control the powertrain, that block diagram we see first. To motivate the discussion of engine control and sensor actuators, it is helpful to review the sensors and variables and measured and control variables. So there are two things: the sensors and measured variables and the control variables or actuator. So the sensor or measured variable goes toward inside the ECU. It goes from the external to the inner side, inner control part of the vehicle. And there the decision is made what is to be done. Suppose speed is less, speed is to be increased of the vehicle. So first the speed is sensed, and then the signal is taken towards the ECU. ECU understand speed is less. Okay, then ECU take the decision, yes, speed has to be increased. So then it will be actuating according actuators, and which will help to increase the speed of the vehicle. So a simplified system block diagram schematic of a model electronic engine control system is shown in the next slide. It illustrates most of the relevant sensors used for engine control. So first we will be seeing one very good big block diagram, and which also will be asked in the exam. So that is actually the engine control block diagram. So this is an electronic engine control system. You can see the top block is the engine control. Okay, and what all blocks are connected to it. So there are almost 8 arrows which are coming in or going out from the engine control, you can see. So in the left side of the engine control block, there are 2 incoming arrows. One is coming from MAF, one is coming from TPS. We will discuss what is MAF, what is TPS today itself. So there is coming an inlet air. Okay, so full throttle, whenever we are saying what is the throttle, throttle means we are inputting too much of air in the system. So there is TPS. Okay, so what is the TPS? The position of the angle throttle plate sensed by the throttle position sensor. So TPS is the throttle position sensor. And what is MAF? Maybe it's something related to air sensor or something. So we'll see what is that. So engine control, so left side there are 2 signals which are coming towards this. That is, there are 2 sensors, TPS and MAF. And depending on what other inputs are coming, so one input is coming from coolant temperature sensor. Okay, so car engine gets very much heated up. What we do is we reduce the power so that engine gets time to cool down and all. Okay, there is another thing coming. This is a very important question for exam: crankshaft or camshaft position sensor. So this is also coming towards the engine. There is another thing which is called as EGO. Okay, so that is also sensed, and so there are, you can see there are mainly 5 sensed parameter which are coming towards the engine. So you have to categorize from this block diagram. So whenever you are writing this answer, you have to do in a categorized form. So first thing is engine control. Engine control is having 3 outlet parameters. So output parameters are, first thing is EGR, which is coming from engine control towards the output side, EGR. And there is fuel injection. Okay, so there will be actuator between the engine control and fuel injector. So actuator is here. That actuator will be controlling the fuel injector. That actuator will be actually controlling the ignition system. Okay, so here it is coming. So here it is engine control, and below it is engine. And engine are getting actual input only from fuel injector and ignition system. They are not actually sensed or measured inputs. They are actually, command is coming from the command control to the fuel injector to the ignition, and from the ignition and fuel injector, they are the inputs. They are coming to the engine to start the engine, to control the engine speed, to control the output of the engine and all. Okay. So main thing is engine control. This is the brain for the engine. So if you say engine is the body, brain of that is engine control. That's why all the sensed parameter goes to the engine control. So this is the brain of the engine. Okay. So MAF is one input parameter. Then TPS is another input parameter, Then EGO is another input parameter, crankshaft position is another engine parameter, and coolant temperature of sensor is another engine parameter. So these are the 5 engine parameters which are coming to the engine control, and depending on, there are some other parameters as well. Depending on the values of these parameters, engine control is taking decision. So three are the output parameters: fuel injector, ignition system, and EGR. So there are actuators in all these places, between engine control and fuel injector, between engine control and ignition, between the engine control and EGR. Okay, so what are full form of all this? We will see. TPS is one thing I have told you, that is a throttle position sensor. MAF, EGO, and EGR we will see today. So I think there is nothing very big, difficult thing in this block diagram. This can be drawn very easily. But yes, you have to remember how many connections are there, who is connecting to whom, and what is the direction. So inlet air is coming from here to the TPS, and engine control is coming to know how much is the air inlet, what is the mass of that. Okay, and then this all air is coming to the engine. So air is coming from the left side, fuel is coming from the top side. Ignition system we have seen last day, that is how the ignition coil is increasing the voltage in the secondary, how is a spark plug producing the spark, and combustion is happening. So after compression, combustion happens. Okay, so all this ignition control is happening through this part, and this may be the 4 spark plugs for 4 cylinders of the system, and they are actually initiating the combustion process. So fuel is being sprayed from the left, this side top. Air is coming here. So inside engine there is produced a proper stoichiometric combustion mixture of air and fuel, and when that thing is compressed, at that time exactly, proper timing and angle control of the ignition is very important. So whenever air and fuel is perfectly mixed for a proper combustible mixture, then only the ignition is happening. And depending on place, depending on perfect cylinder, the ignition is happening, and it is actually expanding the cylinder, power is being produced, and that keeps on going. Okay, and whatever are the exhaust and outlet, so this is the exhaust and outlet part. Okay, there also other things are there. So EGO may be sensing how much is the exhausted gas output. All those things are there. Okay. So there's a very good system block diagram for the overall engine system, starting from air inlet, fuel inlet, engine control, engine, and different types of sensors and exhaust. So let us go through what is said here. So the position of the throttle plate, okay, sensed by the throttle position sensor, directly regulates the airflow into the engine. So whenever we want more speed, more power, so we go full throttle. Okay, what is meant by full throttle? That is actually controlled by this TPS and all. Does it controls the output power? Okay, so throttling actually controls the output power of the engine, from the engine. A set of fuel injector, one for each cylinder, delivers. So here there are 4 fuel injectors, 4 channels from the fuel injector. That means there are 4 cylinders. A set of fuel injectors delivers the correct amount of fuel to the corresponding cylinder during the intake stroke. So depending on how much is the inlet air, this fuel injector is spraying fluid or spraying fuel accordingly. So more is the air, inlet air, more will be the fuel injected inside the engine. That will produce more output power, and vehicle will be running with higher acceleration. So a set of fuel injector delivers the correct amount of fuel to a corresponding cylinder during the intake stroke. Intake stroke means the air is being sucked. Electronic engine controller maintains the fuel air mixture at required stoichiometry within a narrow tolerance band. So the required stoichiometry is very much important. That means mixture of air and fuel. That has to be perfectly done. So if it is just an example, I'm saying 4 unit of air and 1 unit of fuel. That means that perfect measure of that units are to be maintained. So fuel injector is one of the important actuators used in automotive electronic application. So it is there. So there are actuators here between fuel injector and engine. But the performance of this fuel injector and the command on the actuator is actually guided by the sensed TPS signal which is coming to the fuel control. So this loop you have to understand. So this is the inlet air coming. It is sensed how much inlet air at which rate, engine control it goes. So ECU and all these things are here. Then depending on this measured inlet air mass or rate. The fuel engine control takes the decision. It tells the fuel injector that yes, air is entering to the system at this rate. You generate fuel injection or spraying so that the perfect stoichiometry of air and fuel is created. And this is the closed loop. So this is the TPS to engine control to fuel injector engine. This is kind of a closed loop for the air and fuel system. So electronic engine controller maintains the fuel air mixture at required stoichiometry within a narrow tolerance band. Tolerance band means variation in the stoichiometry. That should be as less as possible. Okay, so if it is said 5:1 ratio, perfectly it should be 5:1 ratio. Okay, and that is controlled automatically inside the vehicle. So fuel injector is one of the important actuators used in automotive electronic application. The ignition controller system fires each spark plug at the appropriate time under control of the electronic engine controller. So there are main two actuators. One is the between fuel injector and the engine. Another is between ignition and the engine. So these are the two actuators. So you can say distributor might be acting as an actuator who is actually generating the spark at the base of the spark plug, and that spark is actually going through the electrode and other thing, and at the head of the spark plug it is generating the spark. Okay, so distributor is initiating the process, and the spark is generated exactly at a proper time at the head of the spark plug, and the combustion process starts. So these are very important things. What I request you to do is please go through the videos, okay, of the ignition system, the extra videos that I have uploaded from YouTube. Then you will understand what is the job of ignition coil, distributor, spark plug, and all. Okay, that understanding is very much required. The exhaust gas recirculation, so that is EGR. Okay, so there is another outgoing signal from the engine control, that is the EGR. So exhaust gas recirculation is controlled by yet another output from the engine controller. So whatever exhaust gas is there, sometimes it is recirculated. So all critical engine control functions are based on measurements made by various sensors connected to the engine in an appropriate way. So there is a proper timing when signals are accepted from each of the sensors to the engine control, and there is a proper sequence and timing with which the engine control controls the fuel injection and ignition. Okay, so who is to address first, who is to address next, who is to address last, all these things are perfectly sequenced at the engine control. So it all runs by a algorithm, because nowadays car are all designed, okay, with microcontroller. So very perfect timing control in millisecond, microsecond is achieved by using microcontroller based system control. So all critical engine control functions are based on measurements made by various sensors connected to the engine in an appropriate way. The appropriate way means proper timing with proper magnitude. Computations made within the engine controller based on these inputs yields output signals to the actuator. So it was already told to you, that is, there are 5 inputs, sensed inputs, which are given to the engine control. Depending on the amplitudes, this engine control takes decision, and actuators are actually actuated depending on the values of these 5 measurements. The inputs from various sensors are to be known first, and then this will be the variables for vehicle control. So first the parameters are measured, and then they are controlled by the algorithm which is there in engine control. And that algorithm can be a predictive type of control, that algorithm can be PI control, that algorithm can be having AI, ANN, ML in it. Okay, so there is the 3 chapters, that is third, fourth, and fifth. Those 3 chapters will be teaching us what are the different control actions. Okay, so that is the control action in a vehicle. The control actions, different control paradigms, different control algorithms, they are actually fit in the engine control part. Okay, so engine control will be implementing all those control algorithms on the variables which are sensed, and the inference will be extracted, and depending on the inference, the signal will be given to the actuators. Actuator will perform accordingly. Car will be in a perfectly stable control state. So this is the overall loop. So these will be the variables for vehicle control systems which are sensed already. Then the actuators and control system output are to be discussed. Okay, so here in this block diagram, whichever is shown in slide number 2 and 3, I am not explaining, okay, each block separately. But if this question is asked, electronic engine control system, overall schematic and explanation, in that case, each block in this, so there are total 10 blocks, and there are very important main 5 input signal and very important 3 output signals. So 10 blocks, 5 measured input signal to the engine control, and 3 control output or 3 output to the actuator. So 8 signals and 10 blocks you have to explain in detail, okay, which are not there in the book of ribbons, which are not there in any book. But if you are asked electronic engine control system, this will be the flow of your writing. Okay, so 8 blocks, what are the function, or 10 blocks, what are the function of each block? Okay, among those 10 blocks, 5 will be sensors. Okay, that is TPS, MAF, crankshaft, coolant, and EGO. These will be the 5 sensors. And there will be actuators for fuel injector, ignition, and EGR. And heart of the system is, you can say body of the system is engine control and engine, where heart is the engine, brain is the engine control, and body is the engine. So everything is happening to keep the engine in a very active and stable operating condition. All the things are happening. So other 9 blocks, they are actually working so that the engine operation is perfect. Okay, so this is the hint given to you how to write it. All the 10 blocks, 5 sensing block, 1 brain, that is engine control, 1 body, that is engine, EGO and EGR, which are exhaust. All this thing has to be explained very properly when this question is asked for 10 marks. Variables to be measured. So only 5 variables we have seen in the previous slide. The set of variables sensed for any given powertrain. Powertrain means generation of mechanical power and how it is transferred to different corners of the vehicle. That is actually called the powertrain, is specified to the associated engine control configuration. Complete understanding of all powertrain control systems and relevant sensors and actuator selection for all car models is necessary for better understanding. A set of parameters that are sensed in a vehicle are listed below. So there are 15 parameters which are listed below. Main 15 parameters, there might be others. They are controlled by digital control configurations because it's a microcontroller based system, which is a digital system, ECU. Okay. So digital control is happening. So whatever control systems you have studied in your engineering, maybe it was all analog control. Okay, so after that everything is digitized, so everywhere there will come the concept of sampling theorem, there will come the concept of sample and hold circuit, and it will be controlled by digital control method. Okay, so what are they, we will see in the consequent controller or control sections. The set of variables sensed in engine control includes are these things. So let us just go through. First one is mass airflow rate, MAF. If you see, there were 2 very important parameters blocks there. So one was TPS, another was MAF. Okay, so TPS is as was shown, throttle position sensor, which is just find out how much air is being inlet to the system, and MAF is mass airflow. Okay, so one is rate of this thing airflow, and one is the mass of the airflow. Both are being sensed. Exhaust gas oxygen concentration. So that is, go to the EGO, exhaust gas oxygen concentration. This one. Okay, how much is the oxygen concentration in the exhaust gas? That is said like this. Throttle plate angular position. That is a TPS. Crankshaft angular position. I think this is the most important parameter for any vehicle, that is the position, angular position of the crankshaft, because depending on that the what is that, distributor works depending on that. Okay, and the fuel ignition and other things, spark generation, all happens depends on the crankshaft angular position. So if you please go through the video, you'll be understanding how there is a contact which is being made and broken during the ignition process depending on the position of the camshaft. Coolant temperature. So when the engine gets too much hot, its performance deteriorates. Okay, so coolant actually is taking out the heat from the engine and other places. So if the coolant is getting heated up, means too much of the heat is being created inside the vehicle. So what is the variation in the coolant temperature? Okay, that is a very big indicator of overall engine temperature and efficiency. So main five parameters are given at the top: mass airflow MAF, exhaust gas oxygen concentration EGO, throttle plate angular position TPS, crankshaft angular position RPM is the unit actually, camshaft angular position. So crankshaft, camshaft, both angular positions are found out, and coolant temperature. These are the very main five parameters which are explained in the previous block diagram, and we will have to study sensor, all these five sensors in detail. Okay. So each of them can be a 10 marks question. Then intake air temperature, ambient air pressure, ambient air temperature, manifold absolute pressure. So that is MAP map. So there is a MAF map which is mass airflow, and there is a MAP map which is manifold absolute pressure. Okay, so a lot of things are related to ambient pressure and temperature. You can check intake air temperature, ambient air pressure, ambient air temperature, manifold absolute pressure, and different exhaust gas pressures relative to ambient. Okay. And yesterday we have seen that at different uh, angles of ignition, or you are retarding or you are accelerating the ignition timing, okay, making it very fast or making it very slow. Depending on that, the exhaust gas component increases. So HC NOx, carbon monoxide, is almost kind of a constant, but HC and NOx, they are increasing if we are increasing the fastness of the spark plug control. So if you are generating spark very fast, in that case HC and NOx production will be very fast, so that will come through the exhaust, that we have seen. So some more parameters: vehicle speed, one of the very important parameters. So we can see in the digital dashboard, we can find every time the vehicle speed, 30, 40, 50, 60, whatever. Gears are actually changed automatically if it's automatic vehicle, depending on this vehicle speeds. Okay, so transmission gear selection position, that also is sometimes seen and shown on the dashboard. The car is in which gear, first, second, third, fourth, whatever. Actual transmission gear in use, and various other pressures at different positions. So how much is the fuel in the petrol tank, and how much is the air tire pressure, tire air pressure, all those things. Inside the vehicle, how much is the temperature, how much is the humidity, whether it's within the comfort level or not. So all those many parameters are there, but main 15 parameters related to vehicle and engine operations are listed here. Apart from that, there are 5 other parameters. Okay, so in addition to measurements of these 15 variables, engine control is also based on status of the vehicle as monitored by a set of switches. Okay, these switches include the following. Number 1, air conditioner clutch engaged. So if air conditioner is there, then the vehicle performance becomes different. Brake on or off. Okay, wide open throttle. So throttle is too much, wide open. At that time, the car performance will be different. Or it's a closed throttle. So it's a wide open throttle, or it's a closed throttle. That means how much is the air inlet in the vehicle or fuel engine. That actually decides how will be the performance of the vehicle. And finally, is transmission gear selection. Okay, so the car is in which gear, this is very important. If we are climbing steep and all, at the time our vehicle should be in first gear or second gear. Okay, so if you are going in very high speed and all, at that time higher gears, that is 4th, 5th, whatever it is. So those are the things that determines. So these are the 5 switches or positions of the gears or clutches that is actually deciding the performance of the vehicle. So these switches are actually air conditioner or clutch engaged, brake on or off, wide open throttle, closed throttle, and transmission gear selection. So these are the 5 switches, and these are the 15 parameters you have to remember. They are actually telling about the performance of the car at any time, and there are sensors for all of this. So this is one very important thing. So this is a MAF sensor, what I am doing. So I'm sorry, that is the header is something different. Header had to be It's a MAF sensor. So mass airflow sensor is this. Okay, so operation of an electronically controlled engine with government regulated exhaust emission. So they have actually told us that this much should be the maximum value of pollutants in the exhaust. More than that pollutant, if you are having in the exhaust, so PUC check and all. So at that time the car will be discarded. Again the cleaning and all those things happens, and then again the car is on the road. So government actually they are regulating the exhaust emissions and the components or composition of gases in the exhaust. So it requires a measurement of mass flow rate of air into the engine. So how much is the mass flow rate of air that is coming to the engine? You can say, see in the block diagram, mass flow rate into the engine. This is the TPS and MAF. So these are the blocks. So TPS we are not studying, but MAF we are studying. This is nothing but the rate of change of air inside the system. Okay, so this is MA dot. So this is MA. E is not having a dot, it is MA dot. Okay, the same is given by the symbol. So mass flow rate of air inside the engine. This is actually what we are measuring. First type of sensor we are studying today is the mass flow rate of sensor. The same is given by the symbol MA, and above M there is a dot. It implies the time rate of change of airflow. That means with respect to time, how much is the flow of air inside the engine? That is actually measured by MA dot. Majority of cars produced since the early 90s use a relatively simple and expensive mass flow rate sensor, which is shown, you can see towards below. Okay, so there's a Wheatstone bridge based, there's a resistor here, which is actually changing its value of resistor depending on the flow rate of the air inside the MAF. Okay, so three constant resistors are kept, and this is a resistor which is actually changing its resistance value depending on the rate of flow of air on it. Okay, so this may be a heated coil kind of a thing. So there are many fundamentals. So this is a heated coil kind of a thing, okay, with a constant heat and with a constant temperature. But now what happens, as soon as the air flows above it, air flows through this. So this is in a cylinder kind of a thing, within a cylinder kind of a thing. So whenever the air that we want to inlet, okay, the air that we want to inlet, that is this air, whatever is coming from inlet air, TPS and MAF. So here that cylinder is kept. Okay, so inside this MAF, actually part of it. So cylinder is a part of the MAF, and inside that cylinder, this variable resistance sensor, it is there. So this RAC is actually a transducer, which is nothing but a heated coil. Okay, if the airflow rate is more on the heated coil, the coil will get cooled soon. And as soon as the coil is getting cooled soon or coil is getting heated up soon, depending on that, the change in the value of RAC happens. And change in the value of RAC happens, that actually changes the voltage difference between V1 and V2. See, this V1 voltage is constant because whatever input we are giving, so there should be an input given to this. It's a kind of a Wheatstone bridge. Okay. So whatever output is being taken across V1 and V2. So input is given. So whenever there is an airflow on this heated coil, it will change the value of the RAC to a greater extent. So that will actually change the voltage at V2. And V1 is a constant thing. So V1 minus V2 will keep on changing depending on the change of resistance RAC value. And resistance RAC value change depending on the value of airflow through the MAF sensor. So this is more or less the understanding of how the MAF sensor work. So MA dot is sensed, that is how much is the rate of change of airflow through this sensor. Majority of the cars produced since early 90s are using this very simple type of MAF sensor. This is normally mounted as a part of intake air assembly. So whatever air is being intake in the car, that is passing through this coil. Okay, so this I1 and I2 two currents are shown. Okay, and whatever airflow is there, that also is flowing through the RAC, which is a heated coil. So this is normally mounted as a part of the intake air assembly where it measures airflow into the intake manifold. It is very strongly packaged, rigidly packaged, so single unit sensor that includes solid state electronic signal processing. So this is a op amp operational amplifier, which is a solid state device. So whatever is the difference between V1 and V2, that is actually amplified by this differential amplifier. So this is not the actual circuit which is given. This is just a symbolic representation. So here there is a Wheatstone bridge which is picking up the voltage difference between V1 minus V2. V1 is constant, V2 voltage is a function of this resistance RAC, and the resistance of RAC is a function of how much is the air flow that is passing through it. Okay, so V1 minus V2 is a function of air flow that is passing through the RAC, and gain of this differential amplifier is given as G. Whatever is the output obtained, V naught or VO, this is actually equal to G into V1 minus V2, where V1 minus V2 is the differential input voltage and G is the gain of this differential amplifier, and G into V1 minus V2 is the output voltage of the overall sensor. So it is said that this is normally mounted as a part of intake air supply, where the measured airflow into the intake manifold. It is a strongly packaged thing, solid state device. In operation, the MAP sensor generates a continuous signal that varies as a function of true mass airflow MA dot. Okay, so little variation in the airflow also will change the resistance of this RAC-T coil or transducer to a little extent. It's a very precise sensor which can sense even very small change in the airflow inside the engine. And that change is picked up with an electronic signal which is given as V0 is equal to G into V1 minus V2. So in this bridge circuit, only that sensing element is placed in the moving air stream whose mass flow rate is to be measured. So actually that air which is coming inside this is flowing through this transducer or sensor. The other three resistances are mounted such that they are at the same ambient temperature TA. R1, R2 and R3, they are at TA, which is ambient temperature. The combination of bridge circuit and the differential amplifier forms a closed loop in which the temperature difference delta T between the sensing element and the ambient temperature remains as the fixed independent of TA, which for an automobile can vary by more than 100 degree Fahrenheit. So we discuss the circuit operation first and then explain the composition for variation of TA. So this is circuit already is explained to you. You have to say that RAC is nothing but a heated up coil. Okay, so that heat may be directly proportional to the temperature of the engine. Ambient temperature is generally less. So whenever the external temperature, whenever the external air with external temperature or ambient temperature flows to this RAC-T, at that time the resistance of the RAC-T changes, because from ambience we are getting comparatively cooler air, and this RAC is actually inside the engine which is already in a hotter situation. Okay. So whenever the external air flows with a very big good velocity, that actually changes the RAC-T resistance. And more is the airflow rate, more is the amount of air flowing through RAC-T, more will be the variation in the RAC-T resistance. That is this resistance, and more will be the variation in V output. And that variation in V output, delta V output, will be picked up as a rate of mass flow inside the engine. Okay, and there's a graph actually. This graph x-axis you can find out mass airflow rate. This is G per S. G can be gallon. Okay, so it is volume per second. How much is the air input to the fuel system or engine system? And output is the V naught. So you can find out as more amount of air, that is MA dot, is there, rate of mass is more. At that time, more and more output voltage is being created. So V output is a function of, I said, V1 minus V2, and V1 is a constant. So more is the mass airflow rate entering the fuel system. V1 minus VO2, V1 minus V2 is actually changing. And as V1 minus V2 is changing, that is actually changing or increasing the value of G into V1 minus V2. Okay, so this is a graph. This is kind of exponentially increasing graph, and over quite a lot of time. So this is the graph for the system, which is called as a mass airflow sensor response. So we could not discuss this sensor too much in detail. I have just told you what is the function of working. So it's nothing but a heated coil with a resistance, initial resistance. Other three resistances are at constant temperature, and this resistance actually changes as per the rate of inlet of air inside the vehicle. And higher is the flow rate, the change in the coil resistance will be fast. So delta of change of the resistance value will happen fast, and that will actually change G into V1 minus V2 towards a greater extent. And that change is actually picked up, and that change is actually a measure of what is the airflow rate, and that signal is taken to the engine flow control, and depending on that value, the ignition or fuel actuators, they are actuated. So only one sensor we could do today. The other sensors we will be doing from the next class.